Good afternoon. I hope I'm loud enough. If I'm not loud enough, just come forward. My name is Johan Hutting. We're going to talk about Spring Native specifically because, well, Spring 6 has been out for 6-7 months now, along with Spring Boot, and it does offer some nice native capabilities. So what we're going to talk about is an introduction to what's GraalVM, how to apply this, and the offering that Spring has for you. I'll wait a little bit until you're all down. No, we don't have a microphone. The microphone's for recording, so... Sorry. Okay. We'll also discuss configuration options that you need if you start using native builds, and I will do a short live demo, providing we have time. Okay. I'm Johan Hutting. I work for a bank in the Netherlands called ING, but it's also quite well known here in Germany as ING DiBa, but we're worldwide in I think 30 or 40 countries. I think in Germany it's actually the third bank, biggest bank, and I work there as a senior developer, but also work in sharing knowledge with my colleagues. So I'm a subject matter expert there, but I'm also organizing meetups, and I'm part of the backend guild where we share knowledge and we invite others as well to talk for us, including a backend summit later this year. My main focus is finding good solutions, efficient solutions, and native does have some benefits that we can use as backend developers, so hence this talk. So to explain what the difference is between ahead of time and just in time as we know it, the standard Java stuff, you know, that's basically source code and the bytecode generated from it. That's been the case for 20-25 years by now. And it's all happening in compile time. However, once you go one step further, the native code and the native executable is different between both platforms. So within just in time, the native code is generated once it's needed, hence just in time. Ahead of time, it's generated on your laptop or in your build street at that point, already moving towards the specific platform that you're developing for. So in the case of a JVM, you can run the code anywhere, but if you generate your code ahead of time, you have to specify the target platform. So if I would build something for my Mac, it would not run on a Linux machine or a Windows machine. That's something to keep in mind. You have to make a new build. I can build for Linux on this laptop, it's a Mac, but then I need Docker and an engine in there to build for that specific platform. This is somewhat important because it does mean that all the work is done before you actually ship the software, which takes a lot of time, which we'll see soon in the demo. So the native frameworks in GraalVM, let's first look at the current native frameworks within the Java landscape and also within the Kotlin landscape. Those are Quarkus, which has been around for quite a while, but even longer we have had Micronaut as a platform. And recently Oracle also started supporting Helidon. And of course, since last year we do have Spring Boot now also offering first-class citizen native support, thereby calling GraalVM, which is, well, I don't want to say basically a JDK because it is, but it does so much more than a normal JDK that you would get, because it also generates all the native code, and there's a lot of optimizations that you need to start building those native executables for your platform. And GraalVM, as stated, it's the glue between those frameworks and actually generating the native code and filling out all the parts needed, which we will see in the next slides. So Spring Native, the original Spring Native was released with 2.0 as an experimental feature, but in 3.0 it has become a first-class citizen. So Spring Native no longer really exists, it's now part of Spring. So whenever you have a Spring 6 application or Spring Boot 3 application, it will support native out of the box. It does a lot of stuff for you. So the original Spring Native was a lot of helper functions, still a lot of fiddling to do to get stuff working and get stuff running. But nowadays the current Spring Boot 3 solution does take care of a lot of those issues for you. I will also demo that later with a REST and Spring Data API that will run out of the box without any changes. So one of the main issues you will run into is resources. Because normally you would just say, oh, my resources are located there in this location, and Java would just load it just in time. It doesn't work like that with ahead of time because you have an executable. It needs to have the data within the executable and accessible at that point, unless you start targeting specific directories. So if you need, for instance, SQL in your application or a text file or an image to display, you need to add it to the executable that's generated. That's something to keep in mind. It doesn't know automatically that you need this. So to get this text file, for instance, in, you will need to specify it. And that can be done in multiple ways. So you can use GraalVM itself and specify some parameters, but that's a lot of work if you have a lot of files. So please don't do that. You can also supply a resources config JSON, which you can also auto-generate. I will show you later on how to do that. And you can use the hints that are supplied within Spring 6. Before they had some small annotations, but now they have a more workable hints system where you can supply some code-based resources, and at that point it will pick it up for you, along with many of the other resources that ahead of time needs, and the GraalVM needs to build the executable for you. Typically, the executable will be built, but once you start running it, it will break. I will also show you that later on. Another important one is the types, because within Java, we can just create classes on the fly when we're running. That doesn't work if you have built an executable already, because the code has to be done at build time. So to supply in this, to help the compiler out with this, you can supply the configuration beforehand. So GraalVM knows I need to compile these Java classes, these methods, because it will cut everything off that's not in there. One of the benefits that this offers is that you get really small executables. And I will also show that later on, because the executable that you get is even much smaller than what you would get with a JVM plus a jar, which aligns nicely with the talk Turk just did about saving energy, saving resources. Because having a lot less memory and a lot less disk space allows you to perform better and faster and more resilient. So the same applies here. You can, there's 5 types, I will cover the rest in the next sheets. You can supply those as a GraalVM parameter, which you shouldn't do because it's really, at a certain point, it's a lot of data that you have to supply at that point. The easiest part is generating those JSONs, or if you're not fully sure, then you can also use the annotations in the code. And as you can see here, register reflection for binding is a nice one to just tell the compiler, I have this class, just get everything from this class. I'm not calling it now at this point, so you don't know about it, but ahead of time. By supplying it like this, it will register it and it will bind all fields and all values without cutting them off. So the other helpers we have is Java Praxis. This used to be a lot of work with the old Spring Native for 2.0, but with Spring 3 it does work a lot better. I haven't had to use this so far yet with my examples. And the GNI, that's useful if you call those, but that's rather specific. And again, you can use a annotation there to call them. I will share the sheets later on, so you can also check the links by yourself. Libraries is an interesting one because we don't just build code on Spring. We typically use other code from within our company or other libraries that are helpful for us, like Commons Lang, etc. How do you work with those? Well, I am going to try to switch to my browser screen. Let's see. There is a really nice website from GraalVM, including the frameworks, but they do show you a list of those external libraries and frameworks that work very well with GraalVM. So this list and the level thereof, 1 or 2 stars, is a good indication. And I will scroll down to the Spring parts because that's all 2 stars. It's well maintained, well tested, so every release they do, they will test again if this keeps on working with ahead of time. If you're wondering, can I build without building yourself, you can check your libraries here to see if they are available. If they are not, there is a open source project going on that allows you to supply those metadata, to the reachability metadata for these methods and classes yourself. So if you have some exotic or not that much used library that you do use and you do want to have in your ahead of time application, you can supply the data by yourself for other people to use as well. Of course, if you have an internal library, you can just share it internally, but it would be nice if we have a lot more libraries supported within this open source opportunity. And at the bottom you can see how you can contribute to this. I have the link as well in the sheet. There you go. To generate this, there are several plugins. Those are also listed at the bottom of those pages. But they allow you to either run a normal jar, and then it will extract all the data for you, or you add it to your build tool like Maven or Gradle, and it will generate those files for you, and you can then copy-paste them. Typically, I do take out a lot of the data, because especially the resources becomes quite big, and a lot of those data connected, you don't really need it to run. So it will also result, if you leave all those in a bigger executable, and again, that's not really the point. We try to get as less as possible. We cut off all the JVM stuff, all the compiled code stuff, and then come out with a smaller executable that's faster to run, uses less memory. And as mentioned, we have the open source initiative to add to this to help others also easily run external libraries within the Spring code. Now the exciting stuff, live demo. I do hope not too much will break. There you go. So what I have here is a simple application that prints out a text file. Text file, a simple text. And when you run this as a normal Java application, so this could be your own application that you've built with Spring, it will run quite fast and it will give you a response. Now, the interesting thing here is if I build it like this, if I don't choose the GraalVM JDK, it will fail. So I will show you that first. It's something to keep in mind. And be warned, if it does use GraalVM, it will be slow. As you can see here, it complains it can't find the GU tool that's part of GraalVM to generate a native executable. At the moment, I just use the standard JDK 17, I hope. Yep, there you go. And now we're using GraalVM for the same JDK version. So also expect a new one coming out at the end of this year when JDK 21 is released. So when you start building this, and I will make it somewhat bigger so we can actually see what's going on. Oh, that's quite readable, that's good. This part is just a normal test, which runs fine. It's just like your normal jar. But once it's passed here, it will start generating the native executable. What this does, it checks all the code, it checks all the JDK calls it makes, and tries to filter out whichever classes and methods are not used. So you can have classes that are in your executable that lack half the methods that you normally would have. So if you call Java methods at runtime, you will run into issues unless you specify those beforehand. This should take about 2 minutes. It is quite a bit slower at times. That was my... There you go. So what it does here is it really analyzes all the code that you have. It analyzes the JDK parts that you're calling and then skipping out whatever is not needed. You can also see some references to the libraries it's calling, because all those Spring 6 libraries that it's calling are registered within GraalVM as having the methods and classes exposed, so it knows which ones are used because it does have to know beforehand which ones are touched. And if you don't touch those within the code itself, but through reflection, it will not know about this. Typically, compiling part is about 20-30 seconds, so and that does cut out all the JDK stuff. So this is the same as the J-link that was introduced in JDK 9, resulting in a much smaller JVM that you can use. So instead of making a Docker image with both Linux but also a JVM and your jar, you're just left with an executable application that you can add to it and then skip the JVM part, where the JVM these days is quite large. As you can see, it compiled, so you think, everything is fine. Then you run the demo, and it fails. Oh, because the address is already in use. That's not what I wanted to see. Something here? No. That's annoying. Of course, live demo, everything goes wrong. And where is my... Let's just do it like this. Oh, this one's still running. That's why. So, as you can see here, it does not know about the resource file because it was not marked for inclusion in the output. And to do this, you have multiple solutions. You could, of course, add it to GraalVM itself, but that's not the best solution, because if you have a lot of those files, that will become quite a long call that you will make. One of them is to supply the resource config. So this is a simple JSON file that you need to add to a specific folder. And this is all available in documentation, so it's easy to find out which specific folder it is. And you can supply the patterns here. So if you have a lot of text files, you can say, just add all the text files, all the JPEGs, all the HTML, it's fine. In this case, it's only a specific file. So now I will run the build again. And because it will take some time. The build file itself is nothing more than a call to... Can you go? Thank you. Nothing more than a Maven command that calls a native profile and tells it to compile for native. This is all you need within Spring Boot 3 to get things up and running, assuming you added the native Spring Boot starter, of course. So while we wait for this to continue, you can see here how much space is used by those JDK. So normally, if you would make your Docker image, if you would JDK 17, it is a little bit smaller. Fortunately, they did cut some stuff out, but it's still 283 megabytes that you're shipping every time that you deploy your Docker image. And most of those things you don't really use, because the JDK is offering so much functionality, and if your application is quite simple, like in this case, just printing a piece of text or just having a REST endpoint or a JPA data construction, then you don't need all the other stuff that the JDK offers to you. And we'll switch back to my build as it moves out. So it's now hopefully almost done. As you can see, the analysis takes a lot of time. At the moment, no. There are some flags to make it a bit faster. I tried it and it saved me 10 seconds on 2.5 minutes. That disappointed me a bit. But it's not like C and C++ that you can only build parts. I do hope they will add that soon, because it does help out a lot. But it has to come from the GraalVM team, so that's not something that Spring will offer you. You have the same issue with the Quarkus. If you build a native image, Quarkus does a lot of nice stuff with the dev mode, but it's all not native. That's their own framework on top of Java. And the same with Micronaut as well. So they all suffer from the slow speed of compiling. As you can see, 2.5 minutes exactly. So all I did was just add this simple configuration that says, hello, include this file. And it shouldn't complain about the port in use now. But as you can see, it started up and it does have the text because it's now included in the executable. Let me see how large the executable is. And just for kicks, let's also look at the jar file itself. So this entire application, which does include a REST interface and Spring Data, altogether is 82 megabytes big, including all the JVM stuff. So you don't need a JVM at all at this point. If you only do the text printing, I think you can get it down to about 25-30 megabytes. And there is a talk about compiling stuff, zipping stuff, and fitting it in, I think, 1.5 megabytes. Just a simple text print with Java. As you can see, the jar itself is 180K, so all the libraries included is 23, so the JVM stuff should be about 60 megabytes. All the other JVM stuff, the 280 megabytes, we don't need that. So the other thing I wanted to show you is that we have, come on, that's me, thank you. Yeah. 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 So the question is if you include all the extra binary files, they're all included in the executable because you supply those in the resource config. So you tell basically the compiler, I have all these files, I want you to take them because I don't have them available in the native executable at runtime. So you run into the issues that I just showed you. It compiles well, but once you run it, then it will complain, I can't find this file. It's not there. It is there compile time because it's on your file system, but it's not there in the executable that you ship. So you can call external binaries, but then you have to use the explicit path to call them. Like you would load a text file from your root, then you have to supply the path where it is. This is a small application that basically starts up a REST endpoint API with a simple task repository and a task that has a status completed and some text. This is all the ordinary Spring stuff you do if you build a simple REST API. And as you can see, it returns from the repository find all. You could of course add more endpoints, do some logic with it. And you would expect this to be more difficult. So when I did this with the Spring Native 2.0, the experimental one, this did take some effort. They did improve upon this with Spring Boot 3, and it's now completely flawless. So you do include resources. Keep in mind that I'm not including a resource config here, so it does know about it. This is logic that's within the Spring implementation of building these native files. And we have a simple scheme as well. So all these files, there are some default files that it accepts. It will add to your executable, so you won't run into any issue once you build it and release it. Just in case, I will make sure I am running the... Before I do that, let me first start it and show you that it works. Yep, it's up and running. And as you can see, it's all quite fast, simple code. So for this example, it's not that nice to show because you do have a fast responding, fast starting. It does use a lot of memory. But if you have a complex application like the one you normally work on during the work days, it's interesting to check out what is the impacts of those applications once you start to make those native. So all it does is quite simple. You have an H2 database, you've included the data, and it's displayed instantly. Now I will build it native again, which again takes about, there you go, 2.5 minutes. On my fast laptop, I do have a modern laptop, so if you do have a slower laptop or you're building in the cloud like Azure DevOps or on an internal machine, this might be slow for you. And be aware that you do need the GraalVM JDK to build this. As I showed in the previous demo, the GU, when it says I can't find it, that means you need the GraalVM. Then you have a normal JDK running. So again, it does all the logic. It also checks out all the Spring Data stuff, including the, and that's why it's interesting, including the interface. You don't have to do anything for this. This is all handled for you internally within Spring. Try to make it larger again. Since we have to wait if there's any questions.
Talking about Spring Data, would it include also some different database drivers like Postgres or something?
Yes, yes. So the question is if you use Spring Data, are other drivers also included? The website I just showed you also has those listed. So most of the big time database suppliers, those are supported. So Postgres, MariaDB, etc. It's Oracle even. Yeah, H2 of course, it's running with H2, so out of the box. Yes?
How many native services do you have in production?
We are working on that. So for us this is, because it all depends. There are some cases where native does not have a benefit for you. And I will also mention those later on, what the downsides are of running native. We are running with Quarkus a couple of applications, but those don't run native. And those do run in production. And like I mentioned, we build our stuff within external servers, so you do have to have GraalVM there. So getting that done also takes some time and effort. I do work at a bank, so we do have our security also looking at our back, unfortunately. Yeah, it's almost done now. There you go. So with this, I didn't add any specification, any other clarification towards GraalVM. It builds, running without an error. And as you can see, it works out of the box, native. So one of the main benefits that you have and that you don't really see here is the fast startup time. And this is very nice if you run a Lambda function in the cloud. But if you don't, then yeah, it's how often do you restart your API? If you do it too often, usually something is wrong. So what is nice is that it does use quite a bit less memory. I do hope I remembered the command correctly. This is the PID. And as you can see here, this is a full-blown API running with 103 megabytes. Without me touching something. 103 megabytes for the entire application in memory. And if you run it with a JVM and a jar, it will use more. I don't have that handy, unfortunately. So when you have an application, you can sometimes just try to run it native, because some stuff works out of the box. And if it doesn't, you should supply some extra hints towards the the compiler, which brings me to the other solution, which is this. So without specifying a resource config file, what I did here is that I told the compiler that I do have some hints. And those hints, this is a Spring helper, allow you to specify, because you as a developer know which files do I need, which methods do I need, which files or classes am I serializing. You can supply those here. And of course you can do that in a separate class as well to keep, because this is a small one. But I can imagine if you have a complex application that it can become quite big. This also just works. Let's see how much time I have. Let's try it out then. So, which one of you in the audience is already running with Spring Boot 3 and Spring 6 at the moment? Because I think somewhere mid-November they will stop supporting Spring Boot 2. So many of the people still running on 2, they will have to migrate to 3 by that point, but also have to migrate to JDK 17. That is something to keep in mind. Well, this runs. Any other questions or? Yeah.
It's possible to run tests against
Yeah, it is. Yeah, it's with this. By default, it's turned off because it does take a lot of time. And what they did with Spring Native 2 is that they told you to disable it because you were built native twice when you will run a build. So when you want to do it now, you can use a test compile at that point, and then it will run a native test, the same one that you saw before. So then it will run both the normal Java test and the Spring Native test at that point. Because one of the issues that you do have, because everything is native and a lot of stuff is cut out, you cannot just say connect to this instance and let me debug it like you did before. All the JVM stuff is out because you don't use it at compile time.
And build times are much longer.
Yeah,
Developers then just normal compile and I use just Jenkins to build native? Or
No, I would say during development, because the compile times are quite long. During development, just build the normal Java application like you used to. And then just before you're satisfied it should be okay for test, then do one native build and test that one, including the native test he mentioned. That way you do save all the time. Because like I mentioned, there's a parameter to skip some stuff. It also mentions don't run this on production, but it only saves you like 10 seconds. So if it would be a minute, then yeah, I would be happy, but 10 seconds is just not enough. You will still be distracted by other things. You will go grab a cup of coffee, so you're out of the zone at that point, and that feels like a waste. So as you can see here, it compiled again. This one, as you can see here, it didn't say to use the hello world other than having it here. Don't tell me the port is in use, it is. There you go. So again, there's multiple ways to supply the data needed to compile. And well, these are them. It's at least the most practical ones. It's like I mentioned, you can also supply those to GraalVM, but that's really madness if you have a lot of those files. Yes?
Configuration possibilities of the native runtime, is this the same to the JVM variant? Can I do specify application properties file next to the runtime executable?
Yeah, so is it the same to the JVM build as compared to the native builds? What happens is because you use the Spring native tooling from Spring Boot, it will include the Spring property, the application properties for you. So you cannot have an external application properties unless you load it in specifically from a specific location. That's the downside, because it has to know where those files are. So within a container you could say, oh, it's always in the same location, easy, and then just use the full path. That should also work. That's more difficult, yeah. There are some tricks around that to supply GraalVM with some triggers like, oh, hey, do check this one at this point. But a lot of runtime stuff that you're doing, you can do a lot in runtime, but not all of it. So you do run into issues there at that point. I don't think there's an issue, for instance, to pull the logback XML and then, oh, it's changed, log it elsewhere. That doesn't work. Yep.
Is there a possibility to use a walk path, something that the path is relative to the executable itself?
Yeah, you mean the paths?
Where
Yeah.
it's,
So like in the same directory, at that point you could use /. That does work because it knows where it runs, and you would have the same solution within your Docker container. So that does work out. Yeah. One thing that you do have to be aware of is that the performance is great at first. So that once you start it up, it's lightning fast. It does start responding much faster. It can handle much more load before it starts bogging down. But if you compare it to the JVM solution, over time that will catch up and perform better. So they did come up with a solution for this, and that's to generate profiles and supply those to GraalVM before you build. So then at that point you build an application, you start profiling it, and after you've profiled it, you build it again with those profiles, and it should perform give or take the same. I think the examples that I seen were like 3-4% less over time. And what they did was just call it 10,000 times, 20,000 times, and after a certain point in time, then the JVM, due to the just-in-time, it would compensate the load. It knows which methods are called, which classes are used. It will optimize for that, and it does that afterwards, so not ahead of time. You will compensate that with those profiles, and that's described in this PGO. If you search for that term, GraalVM PGO, it has a clear explanation on how to resolve that. Let me see if I can. Actually, I think I have it open somewhere. This one? Yeah. So they explain how to do this, how to test it, and to supply it towards your generated code to the GraalVM. And this can also be done within Maven and within Gradle. So if you start experimenting with this to see if it's viable for you to use this, I do advise you to do this as the second part. First, check if you can actually compile natively without too much hassle. If you have to do too much tinkering, then it does feel like adding a lot of complexity on top of your API. And if the benefits are not that great, then maybe wait for another solution. If my clicker works, yeah.
how is it about adding flags? I mean, I can configure my JVM at start time
Mm-hmm.
to have some thread count or maximum threads of count.
Yeah, memory.
Mm-hmm. Or something else. Or for example, garbage collection.
Yeah.
What is with the
It's not there anymore because that's all JVM just-in-time stuff. So you cannot say I give you 2 GB of memory max. It will just use what is available until you run out of memory. Because those are all parameters to the JVM itself. And those parts are cut out if you make the executable. Yes?
about tooling, for instance, FedDump or DeepDump or something like that. If I have some problems, normally in JVM I can
before kill, please generate a heap dump and
Mhm.
I can analyze where are the issues.
I think there's a tooling for this now to do this in the executables, but it wasn't there beforehand because that's also part of the JVM cutout. So I'm not sure what it's called. I did see it a month ago. It does allow you to make a heap dump at that point because you do lose a lot of the JVM stuff. So you won't get a heap dump as you had it before. It won't have all the functionality. The same way that you can't connect JVisual VM to your, because there's no real VM anymore. It's all natively running. That's the downside of running stuff native. Yeah. I'm running all of this with the community edition. So there's a enterprise edition as well that should support some more things and should perform better. But I haven't used that because we don't have a license for it. But it is worth investigating. The previous presenter also mentioned that it does perform somewhat better, also in a green perspective. So the optimized code is a little bit better. So the takeaways, there are a lot of nice things about this ahead of time stuff. It does start up a lot faster. It uses a lot less memory. And if you do have machines that are quite full, then you can run more on a specific machine. So that does help you out. If you have a server park that's limited, you could think about maybe make this native so we can run more software, more performant on our platform as it is. Another thing to keep in mind is the debuggability. That's a bit less, as just mentioned. So you do lose a lot of the JVM stuff. You can't just connect to your JVM anymore because it's not there. The debugging is there, but limited because, again, you have a native application. So it's almost like debugging a C application that's compiled. And the build times, as you could see in the demo, are quite long. And there's no, at the moment, possibility to really improve upon that, unfortunately. So that is something to keep in mind. The classic JVM stuff, that's what we've been doing for the past 25 years, at least if you've developed so long. It does have better performance over a long time. So if you have a REST endpoint that's called with 100, 200 TPS, then it might be better to stick to JVM or look at the PGO optimization I showed earlier to see if that works out for you. And yeah, as mentioned, do experiment with this because as you could see with the Spring Data and Spring REST application demo, it was just the same application. It didn't have to add anything to configure. It just ran out of the box, all native. And maybe your application also only takes a little bit of tinkering to get it to work. And if you do have the benefits, then you get something for free from Spring, which is great. So any other questions?
You mentioned that you already run some application, native
Yeah,
application built with Quarkus, but not yet with Spring.
Now we do use Quarkus within ING for a couple of applications, but they are not running native in production. And we are looking at, because most of our applications are either Kotlin or Java in Spring. This is an interesting step up compared to Quarkus, because Quarkus does use EE instead of the Spring library, which is not too bad, but if all your landscape is Spring, then this is a much easier step up to also maintain over time, because all your developers know Spring at that point. But yeah, the Quarkus guys are looking at running natively, but if you don't really have a reason to, if you only get 10 TPS, then you can run natively, but you don't have to, and you do get all the downsides. So that is also something to keep in mind. You don't have to pick a solution because it's there, but if it does benefit you, why not check it out? Any other questions? And I would like to thank you for your time. The sheets are not there yet. I will upload them later today or tomorrow. So if you're interested, you can take a picture and then look them up.